Okay, good evening, ladies and gentlemen, and welcome to this live session on Monday. Um, and we are going to learn a very interesting concept today about Sigma. Okay, because we are all going to become Lean Six Sigma certified individuals. And we are going to learn about what is Sigma. We are going to decode what is Sigma, how to calculate Sigma, which is standard deviation, and when we say it is a Six Sigma process, when we say it is a Five Sigma process, when we say it is a Four Sigma process, what is that number four indicate, and how do we calculate that? There is a special formula for that as well. So we are going to decode everything with the help of pen and paper, plus with the help of our mini tab as well. Okay, everybody. Let's welcome the new members first. How many of you are new here, attending the live session first time? Okay, attending the Monday, Saturday live session first time. Just give me in the chat box, and first we will welcome you in this beautiful community, and then we will start our session. Everybody, all the new members, just type me in the chat box. Okay, Abhishek ji is new. Very good. Who else? Who else? Type in the chat box. A lot of people are yet to join in. Of course, Monday being a working day, a busy day, so we can understand. Okay, all right. So everybody, just type welcome Mr. Abhishek or welcome Abhishek ji in the chat box, and let's welcome him in this community. And you know, let's extend your entire support to achieve his milestones as soon as possible. Everybody, just type welcome, welcome, welcome. And here we go. Let me start my screen. Let me go to my whiteboard. And yeah, rain is there. Yeah, it's everywhere. The rain has been. So this time we have some early monsoon coming in. And I'm from Mumbai, and our Mumbai is completely destroyed in the first monsoon itself, in the first rain itself. So everywhere it's all struggle. But let's see how many of the people can catch up today. All right. Anyway, so if you miss out on the live session, we get the recording in the masterclass archive, so you don't miss out anything. Okay, I will give you some update about update about for the new members, how to go about it. Okay, at the end of the session. So today's topic is Sigma. Right? What is Sigma? Let's understand this. Sigma is Sigma is standard deviation. सिग्मा आइलैंड सिग्मा आइलैंड में आपका स्वागत है. चलो, सो शुरुआत करते हैं. व्हाट इज सिग्मा? फर्स्ट ऑफ ऑल, सिग्मा इज measure of variation. Sigma is what? It is a measure of variation or variability. Let's make it very simple. Variability, variation. Okay. Now, what is variation? Let's go to the let's first go to the fundamental part of variation. What is variation? Let's understand this. As I always give this example, okay, if you are a Olympic gold medalist, let's say shooter, okay, that pistol shooting is there, no? Okay. Now, if this is the target, so we have target like this, right? So, and there is something, right? It's in the center. Now, if I give you, let's say, 50 bullets or 100 bullets, can you hit all the 100 bullets exactly in this center as an Olympic gold medalist? Give me yes or no in the chat box. Exactly all 100 bullets. And you are not an ordinary human being. You are an Olympic gold medalist. That is why you're the best in the world. Can you hit? Why we cannot hit all the bullets as the champion shooter? Why we cannot hit exactly? Why? Can you just give me one or two examples? Why we cannot hit exactly like this? Yes? Anybody? Just give me one example, one reason. Retraction force variation. Okay, very good. What else? What else? Just give me one reason. Everybody just give me one reason. एक एक रीजन आपके हिसाब से क्या हो सकता है? वी आर ह्यूमन, ओके, वी आर ह्यूमन. Airflow variation, bullet speed, speed difference, concentration, the wind due to multiple variation, wind speed, momentum of the hand shot. There are so many variation. Yes or no? So if I see here, so the bullets, if you see there, the bullets will be hit like this. Something here, something here, something here. Okay, most of the times, correct? If you are very good, so it will be in the center, right? But there'll be variation. Now, if I see this, okay, if I draw this, if I make this tilted, then it would look like this. Majority of the bullets will be in the center. This is, let's say, this is the target. Majority of the shots will be the center, and some of them will be around it. Most of them will be very near to the center, but not exactly hitting the center. It's like, it's like, even if Jasprit Bumrah, the best of the Yorker player right now in the international cricket, he also cannot hit all the 6 balls exactly on the stump. Yes or no? There will always be variation. And that's why in the cricket, we have the wide, lines drawn for the umpire reference. If any delivery which is going outside of that, it's called as wide delivery. Yes or no? Everybody? Yes, I hope everybody understands basic cricket, right? So any delivery which is delivered outside that line, it's called as a wide delivery. There is one penalty run the opposite team gets, and the bowler has to ball the delivery again. Correct? What is that white ball? That white, that line is nothing but specification limit. Yes or no? Specification limit. Everybody understanding this? Just give me yes in the chat box. Correct? So we are talking about here, variation is there. Now, so just extending this, what you can say, discussion. Okay. Let's say if I take 2 pens, let's say these are the 2 pens manufactured exactly on the same day, same machine, the same shift, by the same person, with the same raw material. If I want to check the diameter of these 2 pens, will it be exactly equal? Will it be exactly equal? Just type yes, no in the chat box. Again, let me repeat the scenario. It is manufactured in the same company, same shift, same machine, same person, same raw material, everything exactly same, one after another. Will the diameter of the pen be same, exactly same? Just give me yes, no in the chat box. If I measure the diameter with, vernier caliper or screw gauge, will it be exactly same? Yes, no, yes, no. कितने लोगों को लगता है yes, कितने लोगों को लगता है no? Okay, some people are saying yes, ideally yes, theoretically yes. Some people are saying no. Okay, now understand it. Let's say if I start measuring it, it would look like this. So pen A and pen B. So pen A would be, let's say, 10.0, 10.0 mm. Let's say, for example, I'm just giving a very raw example. 10 mm का एक पेन है, 10 mm का दूसरा पेन है. So you'll say, see, I was talking about, it's exactly the same. So if I increase the resolution, okay, for example, if I increase the resolution of the scale, instead of vernier, I go for screw gauge, where I'll get 1 digit more. Okay, so 10.02, I will get 10.02 here as well. Let me draw a line here. So you will say, see, it is exactly the same. I still increase the resolution further, 10.027, 10.025. Here I will get some kind of variation. As I go deeper, the moment I increase the resolution, Okay, go deeper, go more precise, then I will find variation existing there. And it could be my measurement variation, measurement error as well. But the variation will come. How many of you would observe this kind of scenario? Just type yes in the chat box. As we go deeper. So what do I mean to convey here? What I'm conveying here is when there is no differences, okay, when there is no variation, it is limitation of our measurement system. But variation has to be there. Have you understood this? Just type yes in the chat box. Variation is a fundamental principle of the universe. You cannot have variation. ये हो ही नहीं सकता. Okay, now understand this. What we have learnt in our academics, in our schools and colleges, is the Newtonian physics, the physics which was originated by the Newton's law of physics, law of gravity, the Newton's three laws, all those things, right? Now the physics has gone to the next level. It is like quantum physics. In the quantum physics, the scientists have reached to the level where sometimes the fundamental particles like electron, proton, and neutron, sometimes they behave like a particle, sometimes they behave like a wave. What does it mean? It means even at the fundamental level of our existence, the variation is still there. This is very interesting. So variation is bound to be there in the system. Everywhere you will go, there will be some variation. So you cannot eliminate variation, but we can reduce variation. Okay? Yes. See, what happens is precision and accuracy. What will happen is it will reduce the variation, right? But fundamental, the principle number one, we cannot eliminate it. We cannot make it zero. That's my point. Even as an Olympic gold medalist, you cannot hit all the 100 bullets exactly on the same spot. Okay, so the point is that even Jasprit Bumrah also cannot hit the central stump all the deliveries. Okay, Jasprit Bumrah is, let's say, delivering 10 overs in one day cricket. All the 60 balls, can he hit exactly the center ball, center stump? No, he cannot. Okay, even if that precise bowler also cannot hit it, so variation will be there. And what are the reasons of the variation? The reasons of the variation will be identified by man, machine, method, mother nature, etc., etc. 6 M's. Fishbone. So we identify why there is a variation. What are the man-related causes? What are the machine-related causes? What are the material-related causes? What are the measurement-related causes? What are the method-related causes? What is the mother nature-related causes? Okay, so these are the 6 M's, what we have already understood. Everybody understood? So variation will be there, and we go deeper why there is a variation. To identify that, we use fishbone analysis to actually explore what are the contributors of the variation. Are you clear with this? Just type yes in the chat box. Are you clear? Yahan tak clear hai? Fundamental is clear. Anybody who is not understanding it, please let me know. See, live sessions are there to basically clarify all your doubts. Okay? डाउट क्लियर करने के लिए लाइव सेशन है, तो आप बिल्कुल बिंदास बेखौफ होकर डाउट पूछिए, टाइप करिए. ओके, इसमें राइट, एंड आई क्लैरिफाई दिस. सो यहां तक क्लियर है. नाउ हाउ डू वी मेजर स्टैंडर्ड डिविएशन? दैट इज समथिंग वेरी वेरी इंटरेस्टिंग. बिफोर दैट everybody in your process, do you have specification limit? Okay, in your process. Now let's go back to your own process and give me one example where you are using specification limit, and type in a chat box your own example, your own industry, your own process. Give me one example where you are using specification limit. Okay, I'll give example of a pizza delivery, 30 minutes or free, Domino Pizza, right? So that is where 30 minutes is a specification limit. If you go beyond that, beyond 30 minutes, a loss to the company, correct? Okay, moisture of the product. So can you just give me the tolerance number as well? Can you just give me the tolerance number? Tolerance number bhi dijiye mujhe, so that we can take some reference from there. Ha, very good, very good. Inspection is 4.80 plus minus 0.05. Fantastic, very good. Yeah, fabric weight GSM. Ravindraji, what is the target? What is the lower specification? What is upper specification? Grams per square meter. Okay. तो ये भी आप दीजिए. GSM is grams per square meter for the people who are not aware of it. Assay is 95% to 105%. Target is 100%, which is, I think, the API content, I believe, right? And weight limit from 5.0 to 5.025 kg. Okay, very good. So on the lower side, it is 5. So you cannot go below 5, but on the upper side, it is 5.025 kg. Student wait time less than 30 seconds, plus and minus 10 seconds. Fantastic. Superb, superb. Very good, very good. So these are called specification limit. Now, understand this. Why we are giving specification limit as a range and not the number? Because we cannot hit on the same dot again and again. Correct? So let's take a similar example. Let's take a similar example of, let's say cup of tea. Okay. In this, if customer is asking for, let's say there is 80 degrees centigrade is a target. Okay. And so this is a target. And my upper specification limit is 90 degrees centigrade, which is my USL. And 70 degrees centigrade is my lower specification limit. So let me draw these specification limits here. Okay. Now here we go. We have 80 degree as a, now I'm talking about the temperature of cup of tea. What does it mean? If I deliver a cup of tea below 70 degree, that will be too cold for the customer. If I deliver a cup of tea beyond 90 degree, it will be too hot for the customer. In both these cases, customer will reject it. Now, if I collect certain cups, if I check the temperature and deliver to the customer, now I found that there are some data points which are going beyond 70 degree, less than 70 degree, and some data points going beyond 90 degree, and whatever they are going beyond this are basically rejected. It is called rejection or a defect. Rejection or a defect. Okay. Which is causing a loss to the company, which we call it as COPQ. Everybody type COPQ in the chat box. COPQ. How we will draw it if target is LSL? So it is called a unilateral specification. If you have only one side target, for example, now let's say for the students, we give only one side target. Like you have to score minimum 90%. It is unilateral specification. You can go above 90%, any target above 90%. Okay, but only this. So in that case, we only draw USL and LSL, and we consider LSL as a target. Whatever. In your case, 5.0 and upper specification is 5.025, right? So USL will become 5.025 and LSL will become 5.0. Okay, that also we can do. Right? COPQ meaning cost of poor quality. So understand this. Whatever is rejected, it's directly being scrapped or being reworked. Both these cases, we have to lose some money, and that is impacting our profitability. That is the reason this is, we are losing the cash on the table. More the variation, more the rejection. Remember this statement. More the variation in the process, more is the rejection. And that is the reason we measure how much is the variation, and that is measured with the help of sigma. So if the variation is there, so we measure the variation, because whatever we measure, that only we can improve. Do you remember in our yellow belt session, I speak about reducing our monthly expenditure? How many of you remember that? Just type yes in the chat box. Do you remember that? I always speak about this, that if you want to reduce your monthly expenses, what you need to do first? You need to measure that. first start measuring it, the moment you start measuring it, you will get the control on that, right? If you don't have any measurement, you cannot control. That's the reason. If you want to reduce variation, you have to measure it, and sigma is the variation measurement. By sigma, we measure the variation. Okay, so we measure the variation, we find out the causes by using fishbone, man, machine, mother nature method, etc. All the causes, we find out root causes, we find out solution, and then we take the action and we reduce the variation. And ultimately, what is expected is we reduce the variation, and the process will look like this, where majority of the cup of tea, in this example, majority of the cup of tea will be very close to 80 degrees centigrade, and very less or no degrees, no cup of teas will go beyond specification limit. And that's how we have to basically reduce the rejection or the defects or cost of poor quality. This is a basic fundament. Okay, so sigma is a measure of it. Are you clear with this? Just type yes in the chat box. yahan tak clear hai? With the help of specification, why sigma is important to be measured, and by using this DMAC principle, we reduce the variation. Okay, and by reducing the variation, we reduce the rejection, and that's how we save a lot of money for our company, for our client. Okay, now very good. Now let's calculate sigma manually. Then we will do it with the with the help of Minitab. Then I will tell you how to calculate the 6 or 4 or 5 sigma or 3 sigma. That is something, how do we calculate? That is something which I am going to do. Okay. Now, everybody just, let's do one thing. Can you just type your height in the centimeter in the chat? चलो एक बार height calculate करते हैं, कुछ example लेते हैं, and with that height we will calculate our standard deviation. Okay. Chalo, so I'm just taking some examples. Okay, 157 is 1. Very good. Okay, 165. 165. Okay. 160. What is that? 159 bhi hai. Okay. And what is that? 167 centimeters. Okay. 154 bhi hai. Okay. So I'm just randomly taking some numbers. Okay. And 177. चलो बस इतना, जितने ज्यादा लूंगा उतने ज्यादा आपको कैलकुलेट करना पड़ेगा. Okay, so I've randomly taken 5 people height right now. Okay, so how do we calculate the standard deviation? The measurement, the unit of measurement is centimeter. Okay, everybody? Yes, super. Now so 154, 157, 165, 167, 177. These are the 5 numbers I have taken. I have just arranged them in the ascending order. Okay. Now, let's do one thing. Can you just calculate the mean of this? Can you just calculate the mean average? कैलसी निकालिए फटाफट. आपको करना है मैन्युअली, एक बार कैलकुलेट करना है ये. एक बार मैन्युअली कैलकुलेट करने के बाद then it will become very easy for you. Okay. Can you just calculate this? Can you calculate the mean, the average? How do we calculate average? Add all the 5, divided by 5. And tell me in the chat box. चलो कैलसी निकालिए और एवरेज कैलकुलेट करिए. I'll just wait for you. नहीं, 130 पॉइंट कैसे हो सकता है? हाँ, 164 हो सकता है, 130 नहीं हो सकता. There is some, because there is the lowest is 154, right? So the average cannot be 130.6. 164 सबका आया, कुछ लोगों का 165 आया है क्या? 164, is it 164? Everybody getting 164? Yes. Okay, 164. So average height is 164, which is X bar. What is that? X bar. Average is denoted by X bar. Okay. See, I have not calculated. I'm just going by the majority right now. Okay, I'm becoming democratic. Majority wins. So majority people are saying 164, so I'm writing 164. Okay, because I want you guys to calculate it, and we have randomly taken the numbers. Okay, now what do we do? Now we will calculate the deviation. Okay, how do we calculate the deviation? Let me give you the deviation. Deviation meaning the distance from each and every data point from the mean. I repeat again. Distance of each and every data point from the mean. So for example, deviation 1 is equal to 154 minus 164. 154 minus 164. So deviation 1 will be minus 10. Are you clear? Deviation 2 will be 157 minus 164, which is nothing but minus, how much? Minus 7, right? Minus 7. Deviation 3 would be 164 and 165. So this will be plus 1. Very good, very good. Deviation 4 would be 167 minus 164, which is plus 3. And deviation 5 would be 13. Correct? Everybody with me? So we have calculated the deviation. Just type yes in the chat box if you have understood this. So what we have done is we have calculated the deviation. Yes, everybody? Yes, 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 yes. Very good, very good. Chalo. Now, just calculate the average deviation. Can you just calculate the average deviation now? Now we have calculated the average of the data point, right? Now we'll calculate the average of the deviation. That means minus 10 plus minus 7 plus 1 plus 3 plus 13 all divided by 5. Can you just do this? What is the average deviation? Calculate average deviation. Type in the chat box the answer, please. Calculate the average deviation. Minus 0.4, 0, 0, 0, 0, 0, 0. Yeah, because minus 10 minus 7 becomes minus 17. Minus 10 minus 7 become minus 17. Plus 1 becomes minus 16. Plus 3 becomes minus 13. And plus 13 becomes 0. So 0 divided by 5 is equal to 0. That's where the average deviation is 0. But tell me, does it mean there is no deviation? Understand this. When I can say no deviation, all the data points are exactly at 164, 164, 164, 164, 164. Then I can say there is no deviation. Yes or no, everybody? Have you understood this? If all the data points are 164, 164, 164, then there is a zero deviation. Yes. But in this case, there is a deviation, but the average deviation is coming to 0 because the positive and negative numbers are clashing with each other and they are not giving us the right number. So what the statistician suggests, take the square of those numbers. Okay. So the fourth option is, the fourth step is take the square. Why the square? The square because the square value is always a positive value, right? So minus 10 ka square be 100 ही होगा, right? So it will be 100 only. So can you just take the squared value and then take the average of the squared values, everybody? So d2 square will be minus 7 square, which will be 49. Okay. d3 square will be, d3 square is equal to 1 square, which will be 1 only. d4 square will be 3 square, which will be 9. And d5 square will be 13 square, which will be, yeah. So now you add them up and you take the average of it. Can you just do that quickly? And tell me the number of the average. So you add all the squares divided by 5. What is the number? I'm just going by your calculation. I'm not doing it alone. I'm not doing it myself. Okay. 65.6. So we are taking average of squared deviation. Write this down. Squared deviation. We are taking average of squared deviation, and that is called as variance, which is denoted by sigma square. It is denoted by sigma square. Why sigma square? Because it is the average of the squared value. That is called sigma square variance. And right now it is coming to 65.6. Again, I'm going with the majority. I believe you guys are calculating and not copying each other number. Okay. Now, because we have taken the squared value, now you have to take the square root of that value. Can you just take the square root of 65.6 and type in the chat box? Now you take square root of variance. Okay. Which is square root of the variance, which is standard deviation or sigma, which is coming to 8.09. Everybody got the same value? 8.09 or 8.091, or we can say 8.1. Correct? Everybody got it? And this is called a standard deviation. This is called a standard deviation. Everybody understood this? Just type yes in the chat box. So these are the, 5-6 steps in which the standard deviation is calculated. Clear hai? Everybody is clear about the step, why we have done this kind of steps? Just give me a chat box. Now just try to understand this. Let's consider 8.1 or 8 centimeter. Okay. Now what is the unit of standard deviation? Type in the chat box. Does standard deviation have any unit? Yes or no? Type yes or no in the chat box. Will it have any unit? Just give me yes or no in the chat box. No, yes, no, yes. No, 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 yes, yes, yes. Okay. So a lot of people are saying yes. Some people are saying no. Okay. So the answer to this question is yes, the standard deviation always will have the unit and it will be same as the data set. Standard deviation will have the unit same as the data set. If the data set, our data set was in centimeter, right? Centimeter height. Everybody's height was in centimeter. So the standard deviation also will be in centimeter. And how do I read this? See, the average is 165. Average is 165. Okay. And we have 8, let's say 8.1 centimeter is the standard deviation. What does it mean? It means on an average, listen to me very carefully. Okay. I'll give you a very simple explanation of standard deviation. Every data point is on an average 8 centimeter, 8.1 centimeter away from the average value, from the mean value, 164 value. All the data points on an average are 8.1 centimeter away. Are you clear with this explanation of standard deviation? You can, for a layman's language, it is average distance from the mean value. For a layman's language, technically it may not be the best explanation, but for the layman's, average distance of each and every value from the mean is called standard deviation. More the standard deviation, more the spread of the data. Lesser the standard deviation, lesser will be the spread of the data. Let's say all these data points would be 163, 164, 165, 166, etc. The standard deviation would have been around 2 centimeters. Are you clear with this? 164 के around होगा तो standard deviation would have been 2 centimeters. Are you clear with this? Just give me yes in the chat box. Are you clear? And other example, if we have the shortest person at, let's say, 140 centimeter and the tallest person at around 195 centimeter and all the spread around, the standard deviation would have been 12 centimeter to 15 centimeter. Are you clear with this? Just type yes in the chat box. So if I have more spreaded data, standard deviation will be high. If I have very compact data with less variation, standard deviation will be low. Are you clear? ये fundamental clear हो गया? Sigma, standard deviation is sigma. So we want to reduce the standard deviation. That's our aim. So lesser the standard deviation, lesser the rejection. That's what we discussed. Yes? Any doubt till now? रूट मीन स्क्वायर, नो, रूट मीन स्क्वायर थोड़ा सा अलग है स्टैंडर्ड डिविएशन से. ओके, सी रूट मीन स्क्वायर में डायरेक्टली आप वो डेविएशन का वैल्यू लेके उसका स्क्वायर रूट निकालते हो. ओके, स्टैंडर्ड डिविएशन में हम उसको स्क्वायर वैल्यू करते हैं और उसका स्क्वायर रूट करते हैं. दैट इज द ओनली डिफरेंस टेक्निकली. ओके, So between root mean square and the standard deviation, let's say, for example, if I take absolute value instead of the squared value, okay, if I take absolute value, see why statisticians choose. Now, this is a very good question, and let's understand the explanation of it. Why statisticians have chosen the squared value over the absolute value. What is absolute value? Instead of, let's say, instead of -10, -7, etc., why can't I take only 10, only 7, only 1, and directly take the average and directly take the standard deviation? Okay, so what we are saying here is, instead of that, what they have done, they are giving the more the distance, understand this, more the distance, the squared value will basically exaggerate that. Just try to understand the philosophy behind it. Why the squared values are more chosen? Because more the variation, see, as you go away from the mean, okay, and now of that distance you are taking the square. So you are basically, what you can say, emphasizing that distance more. You are taking square of it. Are you understanding? So that way, more the distance from the mean, and you are taking square. Of course, we are then after that we are taking square root of it. Okay, but as we are squaring that, it is showing us more impactful. Okay, that is the reason standard deviation is considered more technically better. What you can say, better indicator than the other deviations measurement. Okay, that's the only thing. So more the data, greater the standard deviation. More the spread of the data, Abhishek ji. More the spread of the data. It is not more the data, more the standard deviation. More the spread of the data, there is a more probability of having more standard deviation. Okay, जितना ज्यादा आपका डेटा स्प्रेडेड है, स्टैंडर्ड डिविएशन उतना ही ज्यादा होगा. Are you clear with this? Everybody just give me yes in the chat box. Okay, shall we move ahead? Yes? Are you taking the notes along with me? Are you taking the notes? Or take the screenshot, okay? Anyway, the recording will be available. See, Virendra ji, I'll come again. Square of the data क्यों करते हैं? As you go away from the distance, okay? Now, let's say the distance is 2 centimeter, or let's say distance is 5 centimeter. If I take the squared value of it, it becomes 25 centimeter. Understand this? So the intensity of the distance becomes greater. Okay, it is intensified that way. So to intensify the deviation, because that's why the squared deviation are always considered better way. Are you clear? That's the only difference between the absolute distance or the squared distance. Okay. Clear? And another thing is that minus plus signs are also clashing. So to avoid that as well, they take the square. So they get both advantages. Okay. Now let me go to the next point here. Let me go to the next point. Okay. So let's open any. How do we calculate this? So the formula for calculating this standard deviation, if I have to write this formula for sigma, the formula is this. Okay. Or meanwhile, I'm writing the formula. Can you open any blank Minitab worksheet? Any blank Minitab worksheet you can open. Meanwhile, I'm just writing the formula here. So the formula is like this: square root of summation of xi minus x bar square divided by n. Okay, where xi meaning individual, each and every data point, individual data, x bar is the mean or the average, okay, and you have n is equal to number of data points, right? So we had taken 5 data points in this case, so n is equal to number of data points, n is equal to number of data. Okay, so and summation is, all the squares you have to be added, right? And then you have to divide them with the number of data points, and then you have to take the square root of it, because we have taken a squared value of it, correct? So this is the formula for standard deviation. Clear, everybody? Now, have you opened this? Yes. So Pratik ji, I will explain you that root mean square wala with some other example as well. Okay. Hmm? Good. Can you just take root mean square wala formula आप लिख सकते हो इसमें, so that we'll compare the differences right away. Okay. Meanwhile, have you opened the Minitab software? Just give me yes in the chat box if you have opened it. Okay. The new members who have not yet, uh, you know, not yet downloaded Minitab, not yet accessed Minitab, not to worry. We will just observe. Okay. नहीं, इसका कुछ लिंक का जरूरत नहीं. ओके, ठीक है, चलो मैं लिंक भी शेयर कर देता हूं. अगर आपको लिंक चाहिए तो कोई भी आप मैं दे देता हूं. हमें सिर्फ ब्लैंक वर्कशीट चाहिए, हम लोग इस पे भी काम कर सकते हैं. चलो मैं आपको एक लिंक भी दे देता हूं. चलो हाँ, चलो इसका इसका लिंक ले लेते हैं. एक स्कैटर प्लॉट करके एक डेटा है, इसका एक लिंक ले लेते हैं. आप इस पे क्लिक करेंगे. इफ यू हैव लैपटॉप विथ यू, सी मिनिटैब विल ओनली ओपन ऑन द लैपटॉप. ओके, नॉट ऑन द मोबाइल फोन. ठीक है जी. तो ये एक फाइल अगर आपके पास, अगर आपको ओपन करने में दिक्कत आ रही है, तो यू कैन यूज दिस फाइल एंड फॉरगेट अबाउट द डेटा, विल क्रिएट द डेटा. ओके. Everybody, once you are ready, let me know in the chat box that you are ready. Ready, 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 ready. Hope you have the blank worksheet. Don't look at this data. Okay, we will create some data right now in the Minitab. Okay. So I have just in the C4 column, C4 meaning column number 4. Okay. In the C4 column, I have just given the name data. You can also put a name data. If you have nothing over there, you can just put in the C1 column called data. So what I'm doing is go to calc random data normal. Can you just follow this? See, on the top of the menu bar, you have file, edit, data, and the fourth option is calc. Calc meaning calculator. For any calculations or the data management, you have this option available called calc. So in the calc, just go to random data. Go to random data and select normal. Everybody just type that once you are ready. Once you are done with this. Done? Everybody just give me done in the chat box. I'll go very slow here. Okay. Click on that. So this data will appear. Okay. So here it is saying that number of rows of data to generate. Now, whenever you want to calculate anything like mean, mode, median, standard deviation, etc., the recommended data points are 3030. Everybody type 30 in the chat box. पहले 30 chat box में लिखे, and let's keep it in the mind for statistics, for to calculate, mean, mode, median, etc. 30 data points are minimum recommended. So what we'll do, number of rows to generate, we will type here 30. We'll generate 30 data points. Okay. And store in the column called data. In my case, it is C4. If you have C1 column, you select C1 column where data is there. Okay. Correct. Now here, it is just asking the reference. Okay. That how much do you want to generate? Now I'm just giving you a raw example how you can do that. Okay. Because we don't have data right now. That's what I'm just randomly selecting some data. So I'm just selecting the mean at 10. and standard deviation around 1. Okay, just I'm selecting mean here at 10. That's it. I'm not doing anything else. मीन को यहां पे मैंने 10 कर दिया है एंड आई एम जस्ट सेइंग ओके एंड हियर द सॉफ्टवेयर हैज जनरेटेड 30 data points of average around 10 for me. Have you also received this? Just give me yes in the chat box. Yes, very good. Now what we do is go to stat, basic statistics, graphical summary. Everybody follow this? Stat, basic statistics, graphical summary. Yes. Now click on that. In the variable, select the data column. In the variable, select double click on data. It will get selected. Just click on OK. And you will get something like this. Everybody got it? Just give me yes in the chat box. Your data would be completely different than mine. So don't have to compare the data set. Okay. Your data could be completely different. Just give me yes. If you have now, this is what is the standard deviation here. Can you see here standard deviation? So standard deviation is 0.8817. This is called sigma. Everybody got it? Just type yes in the chat box. Very good. Very good. So, so in the software, what we gave the software, that it should be around 1. Okay, so the software with the algorithm has created 30 random data points, and of that 30 random data points, it would be, so it is very close to 0.9, right? So it will be around 1. Okay, now if I go back and change that to 5, let's go back again. Let's go back to the data set. Now, how do I go back to the data set? Let's say, how do I go back to the data set? Here, there are 3 points here. Can you see my cursor here? Let me just point it out. This area, just focus on this area. There are 3 important tabs here, out of which the center tab is for the data. Okay, this tab. If you click on that, you will come directly to the data. Okay, let's do another experiment here. Just quick experiment for our understanding. If I want to generate another set of data instead of this, let's say if I want to generate D2, just आपको करने की जरूरत नहीं, just एक बार देख लीजिए. So I'm just typing data 2. Okay. Now I want to generate the standard deviation around 5. Okay. So I'll go to calc, random data set, normal. Now I want to generate 30 data points, and instead of data, now I want to generate in data 2, which is the second column, which is column number 5. Okay. And here mean will be 10 and standard deviation instead of 1, I'm just putting 5. Let's see what data software is generating. So I have, I have increased the standard deviation here. Okay. So you can see, let me show you the, so graph. stats, basic statistic graphical summary. Now, instead of data, I'm just selecting data 2 and say OK. Now, can you see the difference between these two? Now, the standard deviation is 4.5. It's not exactly 5, but very close to 4.5. But can you see this? Very, very interesting. Where is the other one? Okay, let me just draw the other one as well. So, let's compare these two graphs, okay? The first graph having standard deviation 1 and second graph having standard deviation 4.5. Can you see here the data set is starting from 4 to 20 in the right hand side wala thing, where the spread is very broad, and here the data set is around 8 to 11. Can you see here very, very close with that? It's around 10. Okay, let me draw something interesting here. Let me draw something interesting here. Okay, with groups. So let me just type here. ओके यहां से इसका वही प्रॉब्लम है कि वो इमीडिएटली दिखता नहीं है इफ आई वांट टू ओवरलैप सो ये दोनों भी है इसमें लेकिन वो दिख नहीं रहा एनीवे आई जस्ट वांटेड टू शो यू समथिंग एल्स so I'll just share my data, share my screen once again. So what I mean to say here is, again I will go back to the graphs where you can see here the spread is a little wider when my standard deviation is 4.5 and the spread is a little thinner, okay, when my standard deviation is 0.8. Can you see the difference? Just type yes in the chat box. Yes, much flatter, right? So when the standard deviation is increasing, my curve is getting much flatter. When the standard deviation is less, my my data is much closer to each other. Clear hai? Just give me yes in the chat box. So have you understood with the help of Minitab also how you can calculate standard deviation? So see, you don't never have to calculate it manually ever, because we have tons and tons of data and manual calculation is not possible. That's the reason we have softwares like Minitab available. Okay, now let me go back to some of the fundamental here. Let me go back to the whiteboard once again. And now this is something very interesting. Now when we say 6 sigma, sorry. Okay, everybody till now with me, just type yes in the chat box. Everybody till now with me, just give me yes. Okay, now let me share with you a interesting, very good. Large number of data points, what standard deviation close to 1, or if we have large number of data points also, we have, see, data number of data point doesn't matter. Number of data points can be 500 and still you have standard deviation 1. Absolutely possible. Okay, so number of data points is not a deciding factor. How closer the number of data points are, okay, that will be the most important factor. Okay, now let me explain you a concept called a z value. First, write down the formula. USL minus mean divided by standard deviation. Write down the formula. I'll give you a very classic example with this. Okay, and what is z also I will explain you. So now let's take the example of the same T example, the temperature of the T example. What was the temperature of the T example? The target was 80. Okay, imagine our X bar is also exactly matching our target. Imagine that. It is exactly in the center. Okay. The USL was 90 degree, if you remember. USL was 90 and LSL was 70. Now we are not considering LSL as of now. So let's say if I take 30 data points, imagine I've taken 30 data points. 30 data points I've taken, where standard deviation is equal to, let's say 5 degrees centigrade. because we know the standard deviation will have the same unit of measurement, right? So our samples are in degree centigrade, standard deviation will be in the degree centigrade. So can you calculate the Z value here and type in the chat box? Can you calculate? So USL is 90 degree centigrade minus X bar is 80 degree centigrade, correct? Divided by 5 degree centigrade, which will be 10 multiplied by 10 divided by 5 is equal to 2. Everybody got this? Everybody got this? Just type yes in the chat box. सबको मिला ये आंसर? क्लियर है? So the Z, what is Z? Let me explain you, but let's understand the formula. USL minus X bar divided by standard deviation. So USL is 90, X bar is 80 divided by 5. So 10 divided by 5 is equal to 2. So when the Z is 2, that means it is called a 2 sigma process. Now understand this. For example, now this is very, very important. If you can focus here, that will help. Okay. So let me draw this on a graph here. On a graph here. So this is, let's say, my data. Now this is my X bar and this is my USL. Okay. Now X bar is 80, USL is 90. We have seen that. Now the distance is 10 degree between USL and X bar. The distance is 10 degree. And my sigma is 5, right? So I can fit, understand this, I can fit 2 standard deviations here, okay? Because my one standard deviation is 5 degrees centigrade. So actually, I have a bandwidth of fitting 2 standard deviation, the sigma 2 times. Can you see here? Between USL and between USL and X bar, I can fit 5 and 5. I can fit 2 standard deviation, 2 sigmas I can fit. Are you understanding? Just give me yes in the chat box, everybody. Focus here. Yes, between this 10 degree centigrade ka range, between USL and X bar, I can fit 5 and 5 2 times. Yes? Have you understood this? Just type yes, no in the chat box. Everybody understood this? Give me yes, no. Yes, 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 no, 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 no. जो भी है. No to no. Type no in the chat box. No problem. I'll explain again. So I've just drawn on the graph right now. Okay. What I'm saying is between USL and X bar, the range is 10. Right? Understand this. Okay. Focus here. Focus here. Between USL, upper specification is 90 degree. Okay. And X bar is 80 degree. So on an average, the temperature of the cup is 80 degree on an average coming. Upper specification is 90. Okay. Now I have calculated standard deviation at 5 with our formula. I've calculated. Imagine I've calculated it is coming to 5. Now between the range of this USL and X bar, I can fit 5 and 5 2 times. Clear hai? Between 90 and 80 degree, I can fit 5 and 5 2 times. Yes or no? Anuj ji, are you clear? मैं 2 बार फिट कर सकता हूं जैसे कि मैंने निकाला है ग्राफ में यहां पे देखिए. Just give me yes in the chat box. I can fit 1 5 and 2 5, right? Correct? Very good. When I can fit, now remember this, my sentence. When I can fit 2 sigmas, 2 standard deviation between, yes, exactly, 80 to 85 and 85 to 90. Okay, I can fit 2 standard deviation. When I can fit 2 standard deviation between USL and X bar, that's where my process becomes 2 sigma process. That's where the Z value is 2. When I can fit 2 standard deviation between my USL and X bar, that's where I call it as a 2 sigma process. Okay. Now let me alter this. Now I put a project team and I found out what are the reasons of this variation. I do man, machine, method, mother nature, material, everything. And I found out causes and the root causes. I took the action and then my process has, the variation is reduced. If my variation reduce, what will happen to my sigma? Will it reduce or will it increase? If I reduce the variation, what will happen to my sigma? It will reduce or it will increase. Type in the chat box. Will it reduce or will it decrease or will it increase? Decrease or reduce, right? किसी तो लिखा है increase. Understand this? When I am reducing the variation, my sigma, my standard deviation will reduce. When my variation increases, my standard deviation, my sigma will increase. Are you clear? Simple. What is standard deviation? Average distance from the mean. Average distance from the mean. When I'm reducing the variation, my standard deviation will reduce. When I'm increasing the variation, my standard deviation will increase. Are you clear with this funda? Just give me yes in the chat box. जिन्होंने भी increase लिखा है, are you clear with this funda? Just give me yes. Clear hai? Now understand this. Now understand this. Now, if I make my process like this, very close to the center, so my standard deviation from 5 has become 2.5 degrees centigrade. Imagine this. My standard deviation has reduced because I have worked on my process. I have reduced my variation. My standard deviation has reduced. Now I have recalculated my standard deviation. My new standard deviation, my new sigma is 2.5 degrees centigrade. Now, can you calculate the z-score with the same formula and give me the z value? Type in the chat box. Can you calculate the z-score right now with the standard deviation at 2.5? Can you just calculate the z-score? What is the z-score again here? The same, right? USL, which is 90 degree, minus X bar. X bar is same. We are considering X bar is 80 degree only. What we are reducing is the denominator. Instead of 5 degree, now it has become 2.5 degree centigrade. So 10 divided by 2.5 is equal to 4. When I have Z value at 4, I call this process at 4 sigma process. How many of you got it? Just type yes in the chat box. Now, when I have 2.5 standard deviation here, so my process will look like this. Okay. Now, I can fit 4 times standard deviation here between my USL and my mean. 1, 2, 3, and 4. This is my X bar and this is my USL. How many of you got it? Just type yes in the chat box. How many of you got it? As I reduce the variation, I can fit more sigmas between this range of USL and X bar. Are you clear? As more compress my processes, lesser standard deviation. So I can fit more standard deviations between my X bar and my USL. Can we say more optimize the process sigma value? No, standard deviation will reduce. I'll come to this point. यहां तक सब कुछ, everybody with me? Everybody with me? Just type yes in the chat box. Everybody with me? Now, when I say a 4 sigma process, listen to me very carefully. When I say 4, this 4 value is the Z value. This is actually indicator of process capability. Write this down. Process capability. And when I say sigma, this is nothing but standard deviation, which is actually indicator of process variability. So it is a combination of, we call it as Z को हम लोग बोलेंगे sigma. Just to remember, Z को बोलेंगे sigma. So it is a sigma combination. When I say 6 sigma, that 6 number is a process capability sigma number, and standard deviation symbol is an indicator of the deviation, variation. So as a Lean Six Sigma practitioner, what we have to do is reduce the standard deviation sigma and increase the sigma. How many of you got it right now? Just type yes in the chat box. So our role is to take your process from 2 sigma to 3 sigma to 4 sigma to 5 sigma. When I say 3, 2, 4, 5, it is a sigma score, which is a process capability score. Are you clear with this? Just type yes in the chat box. Clear hai? Just type yes. So it's a sigma sigma combination. More the sigma number, better is your process. So we have to reduce the sigma standard deviation to increase our sigma z score. Got it? ये समझने के लिए exactly basically reduce the variation. Absolutely right. Basically reduce the variation. That is what we have to do. And उसी के लिए हम लोग सिक्स सिग्मा प्रोजेक्ट करते हैं. मैन मशीन मेथड मदर नेचर एवरीथिंग भी करते हैं. How many of you got a bulb on moment today? BO. Yes, got it now. Yes, I got it today. ये क्या सिक्स सिग्मा था ना, ये मुझे समझ में आ गया. How many of you like that? Just type yes in the chat box. Bulb on. Yes, something interesting, something fundamental, cool, amazing, superb, fantabulous. Yes, any concept now which is not understood? Let me answer those calls. In 4 sigma process, can we say the mean plus and minus 4 sigma will be within the USL? Is it? So mean in this entire calculation, okay, one underlying assumption I had, okay? One underlying assumption I had, which is my X bar is exactly in the center. So that is one liberty I have taken just to reduce the complexity of explanation. अगर मैंने X bar को भी हिलाना शुरू कर दिया, that would make the understanding complex. That's what I just fix X bar. I'm explaining that X bar will be exactly at the center, at the target. ये मेरा assumption था, that I have assumed. Okay, but in the reality, X bar also moves. So this Z number keeps on changing time to time. For live conveyor process, yes, we can use it. We can use it. We can use this system for all the live data, for all the live continuous data, whichever we have. So just for explaining the concept, I took that liberty that your X bar is exactly equal to the target. Okay, Pratik ji. So in the real life, no, your X bar also will keep on, varying between your around your target. Yes or no? So कभी ये टाइप पे आएगा, कभी प्रोसेस ये साइड पे जाएगा, कभी ये. So as your process will be swiveling like this, your process capability will also be moving like this. That's why we call it a short-term process capability, long-term process capability. कभी अलग सेशन में explain करूंगा ये. Okay. Mean of the process coincide. Yes, assumption is the mean and the target is exactly coincide. Then this will be absolutely applicable. Okay? Clear? Inversely, exactly. Yes. Now you hit the nail, Abhishek ji. So our standard, so what we need to do is we have to reduce our sigma standard deviation. Isko kam karna hai. And as the sigma goes down, our sigma will go up naturally. So our role is to reduce the variation. As we reduce the variation, our process capability will go up, and up. And better the process capability, lesser the rejection. Lesser the losses. That's the project. That's the profit for the company. If the data is unidirectional bimodal, then the find the sigma value. So whichever way the sigma value is, okay. तो इसीलिए यहां पे भी देखिए मैंने यूनी मॉडल ही लिया है मितेश जी. ओके, आपने यहां पे देखा ना, मैंने एलएसएल का जिक्र ही नहीं किया है. I have not even considered LSL, which is on the other side. So actually this formula itself is a unidirectional. It is only on the higher side. Okay. Are you understanding? So the same formula will be applicable. If it is on the lower side, you can use that lower side. If you're on the higher side, you can use on the higher side. Okay. Now in other session, I will explain you CPCPK wala formula, where we have considered both this direction, where we have considered mean, which is shifting as well. ओके, तो वो हम लोग एक बार सीखेंगे. क्लियर है एवरीबॉडी? सिग्मा क्लियर हो गया, स्टैंडर्ड डिविएशन हाउ टू कैलकुलेट द जी स्कोर, द जी वैल्यू विच इज सिग्मा वैल्यू, and our target should be to reduce the standard deviation and increase the sigma value. That is our target. Clear? Super, super amazing. Now, any question anybody has, you can just ask the question. Type in the chat box, or you can raise your hand just to avoid the chaos. Okay. Otherwise, you can just type the question in the chat box. All right. Now, you can unmute and ask the question as well. If more people are there, if you want to unmute, just raise your hand. Then we will one by one we can unmute. Meanwhile, let me share with you all the new members, especially who have taken admission recently in last 2 to 3 days. Okay. Hope you have received the login ID password. Just give me yes in the chat box if you have. Okay. All the new members, just give me this confirmation. You must save this number 99305 wala number. Kindly save this number right now if you have not yet saved, because from that number you will receive all the updates of the live session or whatever communication we have to do. This will be done through this WhatsApp number. This is the mentor WhatsApp number. If you have any doubt during the study, okay, you can just send a message. This is not for calling, okay, because this is a common number used by multiple mentor. I am also using the same number. Okay. And see, like you, we are also sometimes on a training program, sometimes in a client meeting, presentation, etc. So we cannot, and we have thousands of students across the world. So people started calling randomly. It will be very difficult. Okay. See, if you want to have a call, we can set up a prior appointment, fixed timing, because we respect each other's time value. Okay. But if you have any doubt, just send a message. If the message is very long, just take a screenshot or send a voice message. So this can be okay. So you can send a email communication as well, admin@sparanggaming.com. But email will be a little, will be responded during the office hours by our admin team, etc. So to avoid that, WhatsApp is the better communication. So you can take sparanggaming.com. Okay. So this is where your email ID, if you want to send, and you have master class archive. All right. Master class archive folder in your LMS system. If you have login ID password, master class archive is the LMS system you have. You can see the recording of the live sessions in the masterclass archive. After the session is over, it will be uploaded within 1 hour or couple of hours. Okay. So this is what it is. You can start with the course number 1. You can start your self study from course number 1. Take the notes along with that. Okay. Wherever you get stuck, send a message on the WhatsApp number of admin, and we will be there to support you. Okay. I think that's it from my side. I don't see any questions further. If you have any question. Okay, somebody. Okay, Anuj ji, boliye.
Yeah, there is one thing. We have done the calculation. First example, we have taken the which standard deviation 2, right? And in which we have calculated that sigma value is 2. Another example we have taken, similarly, where standard deviation we have taken 2.5.
Sigma value was 5. In the first case, it was 5 sigma value. Sigma was 5. In the second case, it was 2.5. यहाँ पे देखिए. When it was 5, we calculated sigma as 2. आप ऊपर देखिए. Okay. Then we reduce the variation by using the DMAC framework. We reduce the variation. So the standard deviation reduced from 5, it reduced to 2.5. Now the sigma score has increased to 4. Okay. Sigma, Z has increased to 4. Clear? हेलो अनुज जी, आर यू क्लियर? आपका आवाज नहीं आ रहा है. आप म्यूट हो गए, म्यूट.
Yeah, it's clear now.
Now audible. Are you clear now?
Yes, now clear.
Okay, very good, very good, very good. Super. Sigma can be applicable in LSL as well. Yes, exactly. Sigma can be applicable to LSL as well. Absolutely, yes. What will happen if X bar gets higher than USL? Very good. So what will happen? X bar is higher than USL. So यहां पे क्या होगा? Let's say यहां पे इस प्रकार से होगा. यहां पे पूरा डेटा पूरा यहां पे होगा, एंड ये एवरीथिंग विल बी रिजेक्शन ना. ये सभी रिजेक्शन हो जाएगा. ओके. In that case, your Z value can be negative. it can be negative 2 sigma. ऐसे भी होता है. When your x bar is going beyond your z score, your z score can be negative as well, which is a very poor process. Clear? It can go either side. You have to just calculate. और जितना भी बाहर जाएगा उतना सब रिजेक्शन है. See, anything which is going beyond specification is rejection. Clear? Super, super. Okay, just one thing. Coming Saturday, okay, there could be one change which I can foresee, because Saturday I have a full day training program in Pune. Okay, and there will be some travel, etc. So most probably on Saturday we will instead of Saturday we will have live session on Friday. Okay, you will get the intimation once the program is fixed. We will have the session, but one day prior, and you will, timing will remain same. We'll keep the same timing as our regular timing. Okay, 7:30. But if the change is there, we will communicate the change with you. Okay. If you're not able to attend it, no worries. You can check the recording. But that is what I can foresee, because today morning we were having some discussion with the client, and they want the training program at Pune exactly on Saturday. Okay, on 31st. Okay, so if that happens, then we might have a live session preponed by one day on Friday. Clear, everybody? And we will give you a communication properly on that, accordingly. That, okay? CP, CPK, and Z value. So CP and CPK, CP is the potential process capability, and CPK is the actual process capability, and there is a connection between the Z and CPK actually. Okay, the connection table मैं आपको देता हूँ एक just एक for your information. Okay. So actually CPK और Z exactly same ही है. There is not much difference. Okay. ये Z score हम लोगों ने शुरू किया था. CPK शुरू हुआ था when statistical process control started, and the Z calculation started after 6 sigma inclusion. Okay, that's the only difference. But what if you want to check the CPK and the Z score ka comparison? The table looks like this. See, when my CPK is 0.33, that is what it is 1 sigma process. Okay. When my CPK is 0.66, it is 2 sigma process. When my CPK is 1, it is my 3 sigma process. When my CPK is 1.33, 4 sigma process. When my CPK is 1.66, 5 sigma process. When my CPK is 2, it is 6 sigma process, and it continues. It goes to 2.33, 7 sigma process, 2.66, 8 sigma process. See, 6 sigma पे stop नहीं होते हम लोग. 8 sigma, 9 sigma, 10 sigma पे भी जा सकते हैं. It's not a problem, because it's a short term process capability. Clear? So it's a 1:3 का रेशियो है. सो CPK 1 होता है तो Z स्कोर होता है 3. सो 1:3 का रेशियो होता है इसमें. ठीक है? Good. Chalo. Thank you very much for connecting today. If you wish, you can just check the recording later, okay, and clarify your concept. Okay. Thank you very much for joining. Keep learning, keep growing. About the Friday session change, you will get the intimation on the right time. All right. So till the time, keep learning, keep growing. This is Dinesh Patil signing off. Bye bye. Take care. Good night.